Okay, so for the next part, I'm going to talk about properties of logs because before we start doing problems where we're solving equations and stuff with logs, we need to know some of the properties. So there's three basic rules that we need to know, and these are your pretty important ones. We have the product rule, the quotient rule, and the power rule. And if you remember, we actually have all these same rules for exponents. So that's just another thing that kind of shows you that they go hand in hand. So, what we have for each one of these rules, we have a way of writing our logs in a condensed form or an expanded form. And these two things are always going to be equal to each other. So, for the product rule, what we have in a condensed form would be log of 2x. Now, you guys know that when we have these two things written side by side, 2x, what property is that implying? That's implying multiplication. So log of 2 times x gets expanded, and what we do is we break this apart into two separate logs based on the multiplication. So it's log of 2 plus log of x. Now again, this goes hand in hand with our exponent properties because hopefully you remember when you're multiplying things with the same base, what do you do with the exponents? You add them. So multiplication and addition go hand in hand. Next, we have our quotient rule, which is log of x divided by 2. So that's the condensed form. And one of the difference, too, between condensed and expanded. Condensed, we are trying to write the expression using only one log. Expanded, you expand it out and you write it using more than one log. Now, with your exponent properties, remember multiplication goes hand in hand with addition. So now what goes with division? Hopefully you remember that one. Division goes hand in hand with subtraction. So to expand that, we take what's being divided and we split that apart into two logs that are being subtracted. So log of x divided by 2 is equal to log of x minus log of 2. And then the last one is the power rule. So let's say we have log of x squared. So this is one that you guys actually already used, and the power rule tells you you can take this exponent and you can move it out to the front. So this gets rewritten as 2 times log of x. Okay? Okay, so what we're going to do is we're going to use these properties and we're going to go back and forth between condensed and expanded. So the first one I have is we're going to expand it. So that means we're starting with one of these condensed forms. It only has one log, and we're going to expand it so that typically it has more than one log. So what I'm looking for is what's happening to my components here. So I have x, y to the fifth. So when those are written side by side, I know that means multiply. So that's going to be the product rule. Okay, so multiplication implies the product rule. Multiplication goes hand in hand with addition. So I'm going to write this as two separate logs split right here. So I'm going to have log of x plus log of y to the fifth. Now, hopefully what you'll notice is this second part looks very similar to the power rule. So pretty much anytime you have an exponent, when you are expanding, you are going to use the power rule. So now what I know is I'm going to take this exponent, and we've done this before, and I'm going to move this out to the front. So my final expanded answer, I'm going to have log of x plus 5 times log of y. And that is as expanded as I can get that one. So number 12, and you notice here too, I have a base. Here I didn't have a base, so that's implied that these are all base 10. When you apply these properties, your bases don't ever change. So if the original log was a base 10, which they didn't write any base at all, then that means in the answer you do the same. Okay, so with division, going back up here, division goes hand in hand with subtraction. So where it's divided, that's how I'm going to split it into two logs. So I'm going to have log base 3 of x squared minus log base 3 of y. And again, anytime you see an exponent, you're going to be using the power rule. So I'm going to take this 2 and I'm going to move it out front. So I'm going to have 2 log base 3 of x minus log base 3 of y. And that is my full expanded form. So now for number 13. Number 13 is a little bit weird because we see that it's multiplication, but it's a little bit more complicated than that because we have this radical sign, this square root. So hopefully you guys remember, this one is the one I think that I told you is the most important. A square root is equivalent to a power of 1/2. So if you see that square root, we're going to be using a power of 1/2. So now what I'm going to do, there's actually a couple of ways I can do it. I can go ahead and expand the logs and I can deal with the 1/2 last, or I could use the power rule first and deal with the 1/2 and then expand the logs second. And I think that's the route I'm going to take. So I'm going to move that out to the front. So I'm going to have 1/2 times log of x times y. Now, this 1/2 is being multiplied by this whole thing. So in the next step, I'm going to have my 1/2, and then I want to put parentheses, because now what I'm doing is I'm splitting this into log of x plus log of y. So I want to make sure that I have parentheses so that I know that 1/2 is being applied to everything. And I'm just going to leave it there. You could distribute the 1/2 if you want and have 1/2 log of x plus 1/2 log of y. But it's not entirely necessary. So now going the other direction, now we're going to condense. You'll notice each one of these problems has multiple logs in it, and our goal is we want to condense this down to one single logarithm. So with number 14, I see that I have plus, and I know that goes hand in hand with multiplication. So my log condenses down into one log, and then plus means I take these two things and I multiply them together. So it's 7 times x, or you could just write it as log of 7x. Now, one other thing to note, when you just have log of 7, that's fine. Some people still prefer to put parentheses on those single values, but you don't have to. But if you're taking the log of something that is being multiplied or added or subtracted, anything like that, any kind of group, you do need to have parentheses around that so that we know we're taking the log of the whole group and not just of the first term in that group. Okay, for number 15, I've got subtraction, which goes with division. So I'm going to rewrite this as one log, and now my two values get divided. One thing I want to point out to you also, you technically could leave it like this. However, if you are ever able to simplify, I want you to get into the habit of looking for that and trying to do that. So that's one of those things. We know easily that 9 divided by 3 is 3. So it would be much better if we just wrote this as log of 3. And then on the last one, number 16, hopefully you notice what's different about this one, and that is the 5. So you need to deal with that first. And basically what that means you need to do is you need to do this power rule in reverse. So we need to take the 2 that was out on the front here, move it up and make it an exponent. So when I look down here, I've got this 5 on the front. So the first thing I want to do is make this an exponent. So I'm going to make this log of x to the 5th plus log of 4. Now I can deal with the fact that we are adding. So now I condense this down to one log, and these two things have to get multiplied together. So x to the 5th times 4, the best way to write that is 4x to the 5th. So there's going to be my condensed version. So now I've got one last property, and it's called the change of base formula. In the change of base formula, I want to show you why we use it, because if you look down here at number 17, we're being asked to evaluate. That is very, very similar to some of the ones you were being asked to evaluate on the first video. You knew that 2 to the power of 4 is 16, and if you didn't know it, then you could find it on your chart very easily. So here's the difference. What we're trying to find now is 3 to what power equals 8? Well, when you go on here, 3 to what power, we don't know. There's not a definitive power that we can raise 3 to get 8. So when you have a problem like this, the change of base formula becomes very important. So the general format, if you have log base b of a, you are allowed to rewrite this as log of a over log of b. Okay, and that's going to help us evaluate these problems that are a little bit trickier to evaluate otherwise. And I'll show you how it works. You could actually use this on some of those easier problems too. So if you had trouble with those, this is a good option for you as well. So using the change of base formula, I'm going to do log of 8 divided by log of 3, which right off the bat might not seem helpful. However, if you go to your calculator, we all know that we have a log button. So if I type in log of 8 divided by log of 3, I get an answer. And hopefully this answer makes sense because look, if we raised 3 to the power of 2, we got 9. We want to raise 3 to some power to only get 8. So it should be pretty close to 2, which in this case it was. So hopefully that kind of makes a little bit of sense. So I got 1.89. So here I would change my base, log of 7 divided by log of 2. And I get 2.81. So that's pretty easy. So here log of 4 divided by log of 5. I get 0.86. So if I go back to one of those examples that we did on a previous video, and I'll just write it here, we did log base 2 of 16. So we knew that 2 to what power is 16? We knew it was 4. But if we rewrite this as log of 16 over log of 2, and then type it in, that's going to give us the same thing as well. So we knew that it was equal to 4. So that change of base formula, if you were not so good with your powers and knowing those off the top of your head, this is also a good option because you can still solve those problems and then get your answers pretty easily. So that's an introduction to logs. I'm going to put a short assessment on Edulastic. So hopefully you can find that on there and answer those questions.